Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 4, Lesson 15, Session 3. Learning targets are the same as Session 1 and 2, so I will just continue to the next slide. And it says same or different. So looking at these, I see coefficient variable minus a constant, so a binomial, same here. And this needs to be distributed like so. Actually, we could combine these first, okay? So that is going to be 2 times 2x minus 1 when I combine those and then distribute and get 4x, and 2 times a negative 1 is negative 2. And then this is down here just as 2x. So one way we could look at this is B and A are equivalent. B, A, and C are binomials, where D is a monomial, one term. Okay, so those are the differences and the similarities. Moving along, try it, make sense of the problem. It says, are these two expressions equivalent? Okay, so these are quite lengthy. Let me highlight them. This is the first expression right here, and this is the second. And when it says, are they equivalent, you set them equal to each other. So I'm going to just rewrite 24c minus not plus, minus 36 plus 12 minus 12c plus 36 minus 48c equals the blue one, which is negative 2 times the parentheses, the quantity 18c minus 6. Okay, so the first thing I'm going to do is highlight my coefficients with the variable c. Right here, and right there. And then I'm going to highlight my constants, negative 36 plus 12 plus 36. And I'm going to rearrange these together. So I'm going to write 24c minus 12c minus 48c. And then I'm going to do the constants. So negative 36, and I see a plus 36 here. So I'm going to put those next to each other for a certain reason. And then I have plus 12 over here. And then finally, these all have to equal negative 2 times 18c minus 6. But while I'm at it, I might as well do the distributive property. And negative 2 times 18, negative times a positive is negative. 2 times 18 is 36c. Negative times a negative is positive. 2 times 6 is 12. Okay, so the next thing I'm going to do is I'm going to focus on, whoops, I don't need to do this anymore. I've already rearranged them. I'm going to focus on combining like terms. So all my c's get combined. 24 minus 12 is negative 12c minus 48c. Okay, and this is going to be a zero pair, so those go away, and I'm left with plus 12 equals negative 36c plus 12. I'm just going to leave that like that for now. And then when I take negative 12c and I subtract 48 more, okay, was that a minus 48c? Yes, minus 12c plus 24. 24 minus, oh, that's not negative, my fault. Right there's positive. Okay, so 24c minus 12c is 12c. I had a negative there. Minus 48. I always review and make sure I'm not making mistakes and before I continue. So now I'm going to combine these two. 12c minus 48, well, that's 48 minus 12, which is 36, and you take the sign of the bigger, which was negative. C plus 12 equals negative 36c plus 12. Okay, so negative 36c plus 12, and this is negative 36c plus 12. So are they equivalent? And the answer is yes. Okay, why or why not? Well, your why is right here. You showing your work explains the reasoning. Okay, so this is just talking about back in 1983, the first cell phone was $4,000 and the battery only lasted 30 minutes. Aren't you glad they've advanced? Number 6, during a cell phone sale, Avi's dad buys cell phones for himself, Avi, and Avi's sister. Each phone costs C dollars per month for 12 months. The expression 12C plus 12 times 3/4 C plus 12 times 1/2 C shows the total cost to buy the 3 phones. So over on the right here, it says there's a sale. Buy one phone at full price, you get the second phone 25% off. So if you're getting 25% off, which is 1/4 off, you're paying for the other 3/4. So that's why that 3/4 is there. Third phone is 50% off. So the third phone here, well, 50% is the same as half. If you're getting half off, you're paying half. So that's what these values represent. It says that shows the total cost to buy the 3 phones. So I'm going to write that over here. I'm going to take 12C plus 12 times 3/4 C plus 12 times 1/2 C. Okay, which expression is equivalent to that expression? These down below. So what I want to do is I want to simplify this. 12C is going to stay 12C. And when you're multiplying a fraction times an integer, you can divide first. 12 divided by 4 is 3, and then take that 3 and multiply by the numerator, and 3 times 3 is 9. So this is going to become 9C. Same with this one. 12 divided by 2 is 6. 6 times 1 is 6. So this is going to end up 6C. So I have 12C plus 9C plus 6C. Well, here's an 8 in this one. So now I know C is not equivalent. Okay. Notice these parentheses. 12 times 3/4. So see this 12 and 3/4? If I put that as a decimal, that would be 12.75. That's 12 and 3/4. But if I put 12 times 3/4, that's a totally different thing, because 12 and 3/4 here means 12 plus 3/4. And 12.75 is obviously not equivalent to 9. So B is not correct. You can't just get rid of the parentheses and say it's 12.5. It's 12 times a half, which is 6, not 12.5. Half of 12. Two different things. Okay, so B is gone. So now I'm going to combine these. 12C plus 9C is 21C. And 21 plus 6 is 27C. Okay, so I look here and I see 37.25 C. Well, that's not 27C, so that's not right. And if I take 12 times 2.25, 12 times 2 is 24, and 1/4 of 12 is 4. So that'd be 27. So that equals 27C as well. So A is equivalent. And then E is equivalent, because if I look back up here and I factor out a C at this point, if I took a C out of each of these terms, it'd be C parentheses 12 plus 9 plus 6. And then if I distribute, I get that. So 12 plus 9 plus 6 in parentheses with C outside is also equivalent. So the answer to this is A and E. Number 7. Is this expression and this expression equivalent? So I want to know if those two expressions are equivalent. Let me change colors on this one. So these are the two expressions. We want to know if they're equivalent. So I'm going to write them. I'm going to write 9G minus 11 plus 10G. Now I didn't write this in parentheses because there was nothing out in front, so I can just get rid of those parentheses. And this minus right here, whenever you have a minus, you distribute the negative throughout. And this is going to become plus. And a negative times a positive is negative. So this is going to be plus a negative 12. Okay. And a negative times a negative is positive 11G. And a negative times a positive is negative 13. So this plus a negative 12, I am now going to erase and change it to just simply minus 12. And I don't need the parentheses. Okay. So I have 9g minus 11 plus 10g, that's right here. And this minus 12 is here. And the minus and negative is plus, and minus a positive is negative. So this is the expression without the parentheses. And I'm checking to see if it's equal to negative 3 times negative 10g plus 12. Okay, so I'm going to get my highlighter out. I find that this is really helpful if you could do this. Okay, here's a g, here is a g, and here is a g. And then I have a constant, and a constant. So 9g plus 10g is 19g plus 11g is 30g. Negative 11 minus 12 is negative 23. Minus 13 is negative 35. negative 36. Okay, let me do that again, make sure. 11 and 12 is 23. 23 and 13 is 36, and they were all negative, so it's 30g minus 36, and I'm checking to see if it equals this negative 3 times negative 10g plus 12. So in order to try to make these look equivalent, I'm going to divide out a negative 3. So I'm going to take a negative 3 out, and 30g divided by negative 3 is going to be negative 10g. A negative divided by a negative is positive. 36 divided by 3 is 12. And that is going to equal negative 3 times negative 10g plus 12. And these are equivalent, so it is yes. Okay, they are equivalent. Number 8 is the exit ticket. Pause the video, see if you can do this, come back, see how you did, and we'll take a look now. So I want to know if 2 times 6 minus 3x quantity plus another x is equal to 2 times 3x plus another x plus 12. So I'm going to highlight. Actually, no, I'm not going to do any highlighting yet. I want to do the distributive property. So a positive times a positive is positive. 2 times 6 is 12. A positive times a negative is negative. 2 times 3x is 6x. And then I have this plus x out here that doesn't get distributed by the 2 because it is not in the parentheses. This 2 times the parentheses will give me 6x. Nothing else is in the parentheses, so I'm just going to rewrite it. Okay. I'm now going to combine like terms. So this is going to become 12. Negative 6 plus 1 is negative 5x equals 6x plus x is 7x plus 12. Rearranging this, I'm going to put the negative 5x first and the positive 12 second and set it equal to 7x plus 12. And obviously, negative 5x is not the same as 7x. So this is not equivalent. Okay, these are not equivalent expressions. And that brings us to the end of session 3. Thanks for watching and have a great day. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is lesson 15 from Unit 4, and this is session 4. It's the last session of the lesson. Okay, so start by considering this expression. 2 plus 5y minus 6 times the quantity y minus 2 minus 18 plus 30.5y. What equivalent expression has only one term? What equivalent expression has only one term? So we want to get this down to no pluses or minuses. Okay, so first thing I'm going to do is distribute and get rid of these parentheses right here and here. So this 2.5y, negative 6 times y is negative 6y, okay? And a negative times a negative is positive, and 6 times 2 is 12, minus 18 plus 3.5y. Okay, so then I'm going to highlight my y's, and I'm going to highlight my constants with a different color. Okay, so 2.5y minus 6, that'd be like 6 minus 2.5, which is 3.5 negative. So I'll just do those two together, and I'll combine these two right now as well. 12 minus 18 is minus 6 plus 3.5y. Well, notice what happened here. I have a negative 3.5y. Let me use yellow because that was what I was using. Negative 3.5y plus 3.5y. Well, those are zero pairs, so they go bye-bye. And this is my answer, negative 6. So that is an expression with one term. Negative 6 is an expression. Okay, so that's how you do that. And here's an example. So remember that to be like terms, the terms have to have the same variables or no variables at all, which makes them constants. So it says, consider the expression negative 3/4 times a negative 4f plus 3g plus 8f minus 5g. Write an equivalent expression that is the sum of two terms. So now we're going to have a plus or minus and something on each side of it, and that is called a binomial. Okay, one term back here. Mono meaning one, monomial. Okay, two terms meaning two, binomial. Binomial. Okay, look at how you could have rewritten this expression with more than one variable. So, or look at how you could rewrite an expression with more than one variable. So first thing they did was took this negative 4f plus 3g. So they just rewrote it here. This and this is the same thing, okay? And then what they did was put this f here, right there, and this 8f right here, and put the 3g here and the 5g there. That is just a matter of rearranging, okay? So when we do that, we're putting the F's together and the G's together. So negative 3/4 is still sitting here waiting. And negative 4F plus 8F is a positive 4F. And 3G minus 5G is a negative 2G or minus 2G. So then I have to multiply and distribute this 3/4. Well, 4 divided by 4 is 1, and 1 times a negative 3 is negative 3F. And over here, you take a negative times a positive is positive, so that's going to be plus. And 3 times 2 is 6, divided by 4 is 4, 6/4, or that reduces to 3/2, 3/2. And there is my binomial. So it's negative 3f plus 3/2. Okay, so two terms, a constant and a variable with a coefficient. Okay. Apply it. Are these equivalent expressions? So what do? Rewrite it. 0.5 minus 3 times negative 2x minus 1/3 plus 4 plus 8x. Are these equivalent? Negative 1.5 times 12x plus 7. And I'm going to just move all this stuff over so it fits like so. Okay. All right. Before I do the distributive property, I'm going to combine like terms. There's an x. There is an x. This is a binomial. Nothing can be done there. So I'm going to leave that for now. But I do have a constant here and another one here. So this is going to become 0.5 minus 3 times, and negative 2x plus 8x is 6x. And a negative 1/3 plus 4, 4 minus 1/3 is a positive 3 and 2/3. Okay? And that's going to equal, and here I'm going to distribute. Okay, 12 times 1.5. Well, half of 12 is 6. That means 1/2 of 12. So in other words, it's 12 plus 6, which is 18. Or you could multiply it. 5 times 2 is 10. 5 times 1 is 5, plus 1 is 6. Bring down a 0. 1 times 2 is 2. 1 times 1 is 1. And there's a decimal place. And when I add, I get 0, 8, 1. Okay? So 18, 18. So negative 1/2 times a positive 12 is a negative 18x plus. And then I'm going to do the same here. So how about I make that one a fraction? I just like doing different ways just to show because students don't all think the same. So how about I make this negative 3/2 instead of negative 1.5? It's the same thing. And multiply that by a positive 7 over 1. And that's going to be negative 21 over 2, which reduces to negative 10.5. Okay? So I'm going to write that. So it's minus, it's not plus. Negative times a positive is negative, and it's 10.5. Okay, or 10.5. All right. This 0.5 I'm going to erase. I'm going to replace it with a half. You don't want to have fractions and decimals in an equations. And since there's this 1/3 and this decimal here, either go all decimals or go all fractions. And I prefer to use fractions, so that's what I did. Because if I went decimals, 1/3 is a repeating decimal, and we don't ever want to do that because then we're rounding and we're approximating. All right, so the next thing I want to do is distribute. So I'm going to leave this 1/2 and let that sit and wait. A negative times a positive is negative. 3 times 6 is 18x. A negative times a positive is negative. 3 times 3 2/3. Well, let me change that. 3 2/3 is 3 times 3 plus 2, or 11 over 3. And I'm going to multiply that by 3. The 3's cancel, and I'm going to get just 11. Okay, hopefully you understood that. 3 2/3 is 11/3, and I'm multiplying it by a negative 3. So 3 over 1 is 3 times 11 over 3. That's what I was doing. These 3's cancel, and I'm left with 11 over 1, which is just 11. And a negative times a positive is negative. Okay, and that has to equal negative 18x minus 10.5. Okay, well, this half right here and this 11 right here are like terms. So that negative 18x is all on its own because it's the only coefficient with a variable. And if I have 1/2 and subtract 11, I get negative 10 and 1/2. And that definitely equals 18x minus 10 and 1/2. So are they equivalent expressions? Yes. Okay. That one was a little tricky. Okay, here's another one. We're trying to decide if these two are equivalent. This and this. Are the expressions this and this both equivalent? Both equivalent. So we have to do this twice. So it's going to be 8 times 9 minus 6x plus 11 has to equal, we're trying to see if they're both equal to this, negative 16 times 3x minus 10. So I'm going to combine like terms first. So this stays here. And when I do like terms, there's a 9, there's an 11, and that's by itself. Okay, so I'm going to combine those. So it's going to be negative 6x. That just comes down here. And 9 plus 11 is positive 20. And I'm going to distribute here. And a negative times a positive is negative. 3 times 6 is 18, carry the 1. 3 times 1 is 3, plus 1 is 4. So 16 times 3 is 48x. And a negative times a negative is positive. And 16 times 10 is 160. Then I multiply and distribute here. So I'm going to take 8 times a negative. Positive times a negative is negative. 6 times 8 is 48x. 8 positive times 20 positive is a positive 160. And as you can see, we have the same thing on both sides. So the first one is equivalent. So now I'm going to just draw a line, and now we do it again with the other. So we have 15 plus 3 over 2 quantity negative 32x plus 120 minus 35. And I want to see if that's equal to negative 16 times 3x minus 10. Okay, so it's the same old, same old. 15 has to wait. I'm distributing 3 halves times 32. So whenever you think of this as over 1, 32 divided by 2 is 16. 16 times 3 is 48, and a positive times a negative is negative. So it's negative 48x. Same with over here. 120 divided by 2 is 60. 60 times 3 is 180. Positive times a positive is positive. I get 180. And then I have minus 35. Let me just switch back to green here. I wanted to show my distribution a different color. So this is going to be minus 35 equals, and now I'm going to distribute here. Negative times a positive is negative. 16 times 3 is 48x. Negative times a negative is positive. 16 times 10 is 160. Or I could have just looked up here and I'd already done that. Okay? But it doesn't hurt to practice. So now when I look at like terms here, I see a 15, I see a plus 180, I see a minus 35, and I see a negative 48x all by itself. So that doesn't get simplified. So negative 48x is by itself. 15 plus 180 is 195. 195 minus 35 is 160. And as you can see, they are both going to become equivalent expressions. Okay, so are the expressions both equivalent? And the answer is yes. Okay. Okay, more of the same. We have this expression, we have these, so what we need to do is simplify. So I'm going to take negative 3 times 10m minus 2 plus 3 plus 6m minus 3. And I'm going to distribute. 3 times a 10m is negative 30m. Negative times a negative is positive. 3 times 2 is 6. Add. And I have a 3 here and a minus 3 here. They are zero pair. And I get 6m by itself. So now I have negative 30m plus 6m as like terms. This is a like term to this. Okay, so negative 30 plus 6 is negative 24m, and we get plus 6. So A is an answer, B is not, C is not, and D is definitely not as well. Evelyn chose A as the correct answer. How might she have gotten that answer? A is the answer. Okay. So now that they're questioning that, I'm questioning what I did. So I'm going to pause the video and review this a second. Okay, so I checked through this and I believe that A is the answer. Evelyn chose A as the correct answer. How might she have gotten this answer? Well, look at the work I did, and that's how she might have gotten it. So usually they have a student choose the wrong answer, and in this case, they asked us how she might have gotten the right answer, which is strange. But I was thinking maybe they would ask why D might be the right answer, and that would be a common error when they see a negative 24m plus 6 and not realizing that 6 did not have an m, or not realizing that 24 had an m, and negative 24 plus 6 is negative 18. So that's a common mistake when they take constants and subtract or add them to coefficients. That's how you would get a D. Anyhow, next thing. One study says the United States has 8 parking spots for every car in the country. One researcher found that the total parking space available for each car is greater than the housing space for each person. Do you think there are too many, too few, or just enough parking spaces in your community? Explain why. Right? That's just an open-ended question depending on where you live. I'll move on. In front of a store, there is a row of parking spaces. Cars park parallel to one another, with the front of each car facing the store. And then in the picture, okay, so the store would be over here, I guess. Currently, there are lines painted to fit 10 compact spaces that are W wide. and 12 full-size spaces, which are 1 and 1/8 greater, because 0.125 as a fraction is 1/8. Okay, so that's 1 and 1/8 wide. The store owners think they can repaint the lines so that 16 compact spaces and 9 full spaces fit in a row of the same width. Are the store owners correct? Okay, so here's what they're saying here. Currently, there are lines painted to fit 10 compact and 12 full-size spaces. So, excuse me, I'm going to put 10C plus 12F. Okay, and that has to equal, they want to change it and see if they can repaint this so that we have 16 compact, whoops, wrong color, 16 compact and 9 full-size spaces. So the question is 10C plus 12F equivalent to 16C plus 9F? So in this situation, we have two expressions that are not equal to each other, but what they want us to do now is substitute in the widths to see if they're equivalent. So for C, I'm going to replace with W. So I'm going to say 10W plus 12 times, and here's F, 1.125. I don't like working with decimals. That's the same as 1 and 1/8, which is the same as 9/8 as a fraction. Much easier to deal with. I'm going to use that. So I'm going to say 9/8 W for our F. Okay. And that we want to see if that's going to equal 16 times the compact, which is W, plus 9 times the full size, which is 9/8 W. Okay, so now I just take this 10W down here and I distribute here. Okay, so 4 will go into 8 twice, and 4 will go into 12 3 times. So when I reduce it like that, it's easier to come up with my value. So it's 9 times 3, which is 27 over 2. W. Okay. And that has to equal 16W plus 9 times 9 is 81 over 8W. Okay. Well, 27 halves is 10 is the same as 20 halves. W. Okay. So really what we should do is get all of our denominators the same, which is 8. So to get 10 to be a denominator of 8 instead of a denominator of 1, I have to multiply by 8. 8 times 10 is 80W. So 80W divided by 8 is the same as 10W, but I now have an 8 in my denominator. Plus, I want to make that 2 and 8. In order to get 2 to be 8, I have to multiply by 4. And 27 times 4 is 108. W. Okay? And that has to equal 16W. But again, I want to make fractions with eighths. So 16 over 1 becomes an 8. I have to multiply 16 times 8, which is 48. And that comes out to be 128W. I'm going to rewrite these over here. It's the same thing having it in the numerator, but I don't want to confuse you. So I'll put it outside like this, like that. Okay, so then I have plus 81 over 8W. And since we did this, we won't need to calculate what that actual value is. When we add, we should just see if our fractions are the same. So 80 plus 108 is 188W equals, okay, 8 plus 1 is 9. Let me just draw a line here so we don't mix these up. 8 plus 1 is 9. 8 plus 2 is 10. Carry the 1. That's going to come out to be 209 over 8W. They're not equal. But what are they doing? Currently there are these spaces, and they want to see if they can paint it here. Well, the answer is no, because we are 12 plus 9 is 21. We are 21/8 of a width over. So these spaces repainted would not fit. We have to have them in the same space. So if these were equivalent, or if the new painting was less, it would have fit, but it was more. So the answer is no. Okay, that was quite a challenging problem right there. All right, which expressions are equivalent to this? This is more like what we've been doing, and we have 1/5 x. Now they're introducing another variable. Interesting. Times 5y plus 60. Okay. Okay, so now I'm going to distribute this. So we haven't done anything with x's and y's, but this is all that happens. 1/5 times 5 is simply 1, right? Let me show you. 1/5 times 5. 5 is 5 over 1. When you multiply straight across, you get 1 times 5. Down at the bottom, it's 5 times 1. Anything 5 over 5 is 1. So that just becomes 1. And then x times y is simply x, y. And I don't need to write the 1 because 1 times anything is itself. So it's just simply x, y. You cannot multiply, it's not x, it's not 2x, it's not 2y, it's not 2xy, it's not xy squared. It's just x next to y, x times y. Okay? And then 1/5 times 60, well, that just means 60 divided by 5. And a positive times a positive is positive. And 5 goes into 6 once with a remainder of 1. And 5 will go into 10 2 times. So 60 divided by 5 is 12. And there's an x out here, so that x goes with it. So it's 1/5 x times this, 1/5 x times 60. So I get xy plus 12x. Okay. And now that I have an x in both terms, so look what happens next. We have an x here, and we have an x here in each term. After one term is before the plus sign, one is after. When I have the same thing in both, I can factor it out. And xy divided by x is y. Plus 12x divided by x is simply 12. So this simplifies to x times y plus 12. And that's right here. It's not 13xy. It's not 25x plus 300. It's not y plus 12x. It's not xy plus 60x. It's xy plus 12x. And I don't know what they're doing here. 2/5, 4, 3/5. Let me distribute this and check it. It might be equal. 1/5 times 2xy. So I'm taking this 1/5 and I'm multiplying it by that. Well, 1/5 times 2 is 2/5 xy plus 1/5 times 20 is 4x plus 1/5 times 3xy. Well, 1/5 times 3 is 3/5 and xy plus, and 1/5 times 40 is 8x. So 2/5 xy, notice what happened here. We have a 2/5 xy. We have a 3/5 xy. They're like terms. I have a 4x, I have an 8x. I can add those. 2/5 xy plus 3/5 xy is 5/5 xy, or simply xy. And 4x plus 8x is 12x. So xy plus 12x is right here before factoring. So A is also an answer. So the answer is A and F. Okay, these are getting to be really challenging problems. And we'll move on. Decide if each pair of expressions is equivalent. So if I take 6 times negative 5a, that's negative 30a. And 6 times 4 is 24. 3 times negative 10 is negative 30a. And 3 times 8 is 24. So these, yes, are equivalent. Okay. So this one here, it's going to be 1/6 times 15a. So I'm going to do that down here. That'd be 15 over 6. Well, 3 will go into 6 2 times, and 3 will go into 15 5. So that's going to reduce to 5/2 a minus, and 36 divided by 6 is 6. Okay. So if I have 1/2 minus 3a, 1/2 a minus 3a is a negative. So that's going to be a negative a, and this is positive, so I don't even need to go any further. That's a no. C, negative 3a plus 1.5, and this is already simplified, so to speak. Okay, and so I am going to now focus on this. So I multiply. Negative times a positive is negative. 1/2 of 6 is 3a. Negative times a positive is negative. 1.5 times 0.5 is 0.75, or 3/4. Okay, and this is negative 3a plus 1.5. This is negative 3a minus 3/4. So that is not equivalent. Okay, and finally the last one. Let me erase this work here. Doody-doo. Last one. Negative 4 times a is negative 4a. Actually, let's combine like terms first. So let me get my highlighter. Okay, so here is an a. Here's a 2a. Here's a negative 4. Here's a plus 8. This is going to simplify to negative 4 parentheses. A plus 2a is 3a. Negative 4 plus 8 is plus 4. If I distribute here, I get negative 4a. Negative times negative is positive. This is an a, not a 9. And 16. And then I'm going to get a negative times a positive is negative 8a. Negative times a positive is negative 32. Negative 4a minus 8a is negative 12a. 16 minus 32 is negative 16. If I multiply this throughout, I get negative 12a minus 16. They are equivalent. So that answer is a yes. Okay, these are quite lengthy. Okay, so those who don't write things down on paper are going to be in serious trouble this unit unless they change their ways. You cannot do math without paper and pencil. Okay, number 8. Kazuko says the expression 5x and 6 minus x are equivalent expressions because you can substitute in 1 for x for both and get the same result. Is Kazuko's reasoning correct? So what he's saying is 5x equals 6 minus x. Because if you plug a 1 in for x here and a 1 in for x here, you get 5 times 1 here, and you get 6 minus 1 here, and that's 5, and that's 5. Okay? They're equivalent expressions if x is 1. But a variable, the word vary means to change. So we have to, if they're equivalent expressions, it has to be true for any number we plug in. So I'm now going to just simply change this to a 2. Okay, so if I substitute in a 2 now, here and here, 5 times 2 is 10, 6 minus 2 is 4. Whoops. Okay, so Kazuko's reasoning is definitely not correct. And I could actually solve this and find the values that x could be by using algebra. And we would add x to both sides. This might be a little bit ahead of you, but it's okay. I'm going to show you. Divide it by 6, and then to get x by itself, you divide both sides by 6, and you get x equals 1. So 1 is the only value that x can be that would make these two equal. So Kazuko's reasoning is not correct. Okay, closing. Start with the expression here, write an equivalent expression, explain why it's equivalent. I'm going to stop the video here. All you have to do is distribute the 3/4 throughout and come up with an equivalent expression. But since this is the exit ticket, I will leave this to you. Thanks for watching and have a great day.